All right, in this video, we are going to implement portions of our player mono behavior. The portions that we're going to implement is just enough to control our character controller. Now, the reason I want to do this is we currently have no real way to test our character controller while we're implementing it, but fortunately, we've already stubbed out all of the methods that we need. So all of the public API of character controller 2D has been implemented. That means we can actually hook into that class without having implementations yet, which will allow us to test that class as we add implementation details to it. So what we're going to implement is the bits of the player mono behavior. We're going to handle things like if he's facing right, we're going to handle things like his movement speed. We're going to handle input, like which keys are currently down and which direction he should go, and so on and so on. We are actually going to be requiring some bits of information from our character controller 2D that we haven't exposed yet. So we will be making a couple modifications to our character controller 2D at the end of this video once we know exactly what it is what information we need from it. So let's go ahead and start with our player. I'm going to jump over into Visual Studio and I'm going to jump into our player mono behavior. Then I'm going to remove all of the code inside of it and leave it as simply a public class player that inherits from mono behavior. Then I'm going to write some private fields, some private fields that just keep track of the current state of the player. So I'm going to say private bool is facing right. Not surprisingly, is facing right determines if the player is facing right or not. Next up, we want to have a private character controller 2D underscore controller. This variable will keep track of our character controller 2D component on this game object so that we can call into it and tell it to do things. Next up, I want to create a private float normalized horizontal speed. Normalized horizontal speed will be a value that's either -1 or 1 depending on if the player is moving to the left or moving to the right. Okay, next up, I want to say public float max speed. That will determine the maximum speed that the player can go. And then I also want to have a public float speed acceleration. Speed acceleration, and then we'll do speed acceleration on ground and speed acceleration in air. We'll set the speed acceleration on ground value to 10f and the in air to 5f. So what do these three values mean? Well, first of all, we'll set the maximum speed or the maximum units per second that the player can move. Next, we'll have these guys. These guys determine how quickly the player goes from not moving to goes from not moving to moving, or how quickly the player goes from moving left to moving right. So these factors are used to determine how quickly the player's speed can change, or rather, how quickly the player's velocity can change. And we use two different values, one for if he's on ground and one if he's in the air. Okay, so that pretty much should be most of what we need for what we want to implement. So let's go ahead and implement our public void awake. Or let's do a public void start method. And the start method will ensure that the awake methods of all the other components on this object have been invoked first. First thing we'll do is we'll set controller to get component character controller 2D. Make sure that this is get component and not get components. So this will basically alias out our character controller 2D component into the controller variable. Next up, I want to say is facing right equals transform dot local scale dot x is greater than 0. So what does this mean? Well, this means we are facing right if we are not flipped. This allows us to start a level with the character flipped around the other direction, and the is facing right boolean will start on the proper value. So again, is facing right is true if we're facing right, or if we're not flipped. If we are flipped, that means the local scale's x component will be smaller than 1. It'll be -1, in fact, as opposed to 1. So this just initializes our is facing right value to the appropriate value depending on where we start, so that we are allowed to change if the player is facing right or facing left when we design the level. Okay, so let's go ahead and say public void update. Update is called every frame. Now, we want to do two things. We want to handle the input, and then we want to update the controller's force. So the handle input method, which I have not written this method yet, which is why it's red. The handle input method will change our normalized horizontal speed to 1, -1, or 0, depending on if the player is holding down A or D. In addition, the handle input method will handle jumping. Now, the reason why I'm putting handle input as a method instead of putting it into the update method itself is that we might want to do some additional, or we might want to add some conditions for whether or not we should handle input later in the series. For example, if a player is dead. Now, we haven't dealt with death or dyingness, really, death or damage yet in this video series, but we will eventually. And when we do, we'll want to say if the player is not dead, then handle input, because if the player is dead, we don't want to handle input. So I'm just going to leave that as a method right there, and I'll implement that method here very shortly. But before I do, I want to finish the update method. Now, what the update method has to do at this point is it has to set the horizontal velocity of the character controller based on the normalized horizontal speed combined with the speed acceleration and the max speed. So what I want to do is I want to say var movement factor equals controller.state.isGrounded question mark speed acceleration on ground colon speed acceleration in air. So the movement factor will be set to either 10 or 5. 5 if the player's on the ground, or 10 if the player's on the ground, and 5 if the player's in the air. And then we'll use this movement factor in the next line when we say controller dot set horizontal force. So we want to set the velocity, the horizontal velocity of the player. And we want to say mathf.lerp between controller.velocity. Now, velocity has not been specified yet, so this will be an error for now. Velocity x, so the from value is the current velocity of the player. The to value is the normalized horizontal speed multiplied by the max speed. And then the t value, or the value between 0 and 1 that we want to use, is time.delta time times movement factor. So what does this code mean? Well, this means every frame will first handle input, and handle input will set normalized horizontal speed to either 1 or -1 or 0. Then we want to set the x component of the player's velocity to a linear interpolation between the max speed that we want to go and the current velocity, using the movement factor multiplied by the time delta time as the value between 0 and 1 to interpolate between. So what's great about this is this allows us to do something like stuff, like lots of stuff. No, what this allows us to do is this code works because max speed, for example, max speed might be set to 10. In fact, let's go ahead and give max speed a default. Not only will this give us a good default to work with, but it'll also, let's do 8. It'll also make this equation a little bit more concrete for you guys. Normalized horizontal speed will be 0, -1, or 1. If it is 1, this value will be 8. If it is -1, this value will be -8. If it's 0, this value will be 0. That is exactly what we want to pass into this parameter of lerp, because this parameter of lerp is the target speed. The target speed is either going to be -8 if he's moving to the left, 8 if he's moving to the right, or 0 if he's not moving at all. So this code interpolates between that maximum speed, determining if he's moving right or moving left, and interpolates that from the controller's current velocity. Anyway, so that is the update method. Again, we haven't added the velocity property yet to our controller, but we will here shortly. Let's go ahead and write our handle input method. I'm going to say private void handle input. Okay, so what do we need to do? First, we need to say if input dot get key code D. So if they're holding down the D key, which is going to be what we consider to be the right key, we're going to set normalized horizontal speed to 1. However, we're going to say if that he's not facing right, then do a flip. So what we're doing is we're first saying, okay, so move him to the right, have him start moving to the right. If he's facing the left, though, flip him, so now he's facing the right. Then we're going to say else if input.getKey keycode.a, that means we want him to move to the left, right? So what we're going to do is we're going to say normalized horizontal speed equals -1, which again, by setting normalized horizontal speed to -1, we are now changing the target value of our velocity.x to -1 times his speed, which indeed will make him move to the left. Then we want to say, if we're wanting to move to the left, but we're facing right, then do a flip. Finally, if the user is not pressing D or A, set the normalized horizontal speed to 0 and don't do any flips. So that means he's just going to stay there. Finally, we want to say if controller.canJump and input.getKeyDown space, then we want to say controller.jump, which will make the player jump. Okay, so we have a good outline of what we have left to write. We have to add the velocity property to our controller. We have to add the canJump property to our controller. And we have to add the flip method to our input. So let's go ahead and do that. I'm going to write a private void flip. And the flip method is just going to, it's going to flip him. So we're going to say transform.localScale equals new vector3 negative transform local scale x, transform local scale y, transform local scale z. Effectively, what this does is this flips the player around. It negates the x component of his local scale. Then I want to say is facing right equals transform.localScale.x is greater than 0. So if the transform local x is greater than 0, then he's facing right. So we want to set is facing right to true. Sound good? All right.
Indeed it does.
Sweet. So let's go ahead and stub out our velocity property and our canJump property on our character controller 2D so that this code will work without errors. Let's jump into our character controller 2D. Let's come up here to where we defined our state property, and let's do public vector2 velocity get private set. Then let's do public boolean canJump. However, the getter is going to be, it's not going to be an automatic property. Instead, the getter is simply going to return false. Why am I doing that? Well, again, we're stubbing things out right now. And because we're stubbing things out, we are not adding any real implementation. But the canJump property will actually have some logic inside of its getter. It won't be an automatic property like velocity. So we'll just have a getter that returns false so that when we know when we fill it in that we have to add some more logic in here. Now that we've done that, we have finished the player script at least as far as we need to go. So basically, you can think of the player script right now as a controller or a driver for the character controller 2D that uses player input as, well, input. This is different than if we wanted to make an enemy, for example, because if we wanted to make an enemy, we would instead write an AI script that also would use a character controller 2D, but wouldn't depend necessarily on user input. Okay, so now that we've done this, let's go into our game. I'm going to locate my main camera. I think I have my main camera all the way off here. I'm going to move my main camera into the game, and I'm going to up his orthographic size. So see, by clicking on that little handle, I'm upping the orthographic size, effectively allowing me to see more of the level. We're going to write a proper camera controller, but we haven't done that yet. So until we do that, we're just going to leave our camera sitting right here while we can play with our character controller. So let's hit run. And the first thing we get is an error. Object reference not set to an instance of an object on player.cs line 24. If we come into player.cs and look at line 24, we'll see that controller must... Oh, no, it's not controller that's null. It's controller state that's null. See, I never actually... Well, no. Yes, I never actually instantiated the state. Because I never instantiated the state object is null, therefore I cannot access the isGrounded property. Let's go into Character Controller 2D and cheat a little bit. In the awake method, I will add a little bit of implementation. I'll say state equals new controller state 2D. So that way our player script can reference the state property of our Character Controller 2D behavior without running into an error. Coming back into Unity, we can hit play, and we see our platforms moving, so that's cool. And if we try to move our player, nothing happens, except he does indeed flip. So that's really cool. But he doesn't jump, he doesn't move, he doesn't fall, he doesn't do anything, really, except flip. That is kind of fun, though. But yeah, he won't do anything until we actually implement our Character Controller 2D. But effectively, that's exactly why we did this first, is so that we now can test our Character Controller 2D without having to worry about adding any user input code. So I think that just about wraps things up. We are now completely ready to dive into the actual implementation of our Character Controller. So we can actually start talking about things like how we're actually going to move horizontally, how we're going to handle gravity, how we're going to move vertically, how we're going to move slopes, and all of that fun stuff, especially once we get to handle platforms. That stuff's going to be a bit of a trip. But I think that just about wraps this video up, so we'll see you guys in the next one.